Secrets of the Hiset Math, Part 2. Use common sense to eliminate answer choices. Folks, I see it over and over again. People who are perfectly intelligent and could do math problems if you were to casually ask them a question in the line at a grocery store, turn off their common sense as soon as they get into the test and pick answers that make no sense whatsoever because they think they're doing the same steps they did on another problem that was like it back when they were practicing. In the last video, we talked about checking your answer by asking yourself two questions. One, did I answer the right question? But the other question you were supposed to ask yourself at the end is, does my answer make sense? This is always smart, but we can go further. A lot of times, even if you're not sure how to do the math, you can ask yourself which of these answer choices do not make sense. Cross those off and guess from the ones that remain. And sometimes there's only one left, so you can actually get a correct answer by using common sense. Please do not turn your common sense off when you go to take the Hiset. All right, here's our first example. This comes from the free practice test number 1 that is offered by ETS, the company that makes the Hiset. On their website, you can download the entire test for all the different sections, including math. And I recommend you do that. If you're not in some kind of class, download all the free tests. All right, an appliance store uses the following formula to set its selling prices. Now, please don't be scared by formula. In fact, don't even look at the formula yet. Let's just think about this. How do stores make money? They buy stuff, and then they mark the price up, meaning they're going to sell it for more than they buy it for. I think it doesn't take a lot of common sense to realize if they sell something for less than they bought it for, they're not going to make any money. They're quickly going to close. So all we have to do is, for the moment, we can even ignore the actual formula and we can just read the question. If the actual cost of a refrigerator is $800, what price will the store set for the refrigerator? And clearly they're not going to set a price of $200. That's way too low. They're going to lose a lot of money on that. Even if they set it at $600, they're still going to lose money. And even if they set the price at $800, that's the same as the amount they bought it for. They're not going to make any money that way either. Plus, even if you don't remember how to do percents, you at least see that they're going to be adding something onto the price. So it can't be $800 either. Now look at that. We're down to 2 answer choices. If time was short, or if you really just had no idea how to do your percents, please learn how to do percents before you go take the math test. But as an example, if you didn't know how to do percents, at least we're down to 2 answer choices. And if you can do that on a lot of questions, even if you're randomly guessing between those 2 answer choices, you're still going to pass the test. Now, we can actually go a little further by just remembering that 50% is the same as half of something. Okay, so even if you don't know how to do any other percents, if you remember that 50% is half, then anything that is greater than 50% is going to be more than half, and anything that is less than 50% will be less than half. 25% is less than 50%. What that means is we're going to take our actual price, $800, and we're going to add on to it some amount that is less than half of $800. Well, half of $800 is $400. So if I go all the way to 50%, my new price would be $1,200. Okay, so I can calculate 50% because I know how to take half of 800. Well, we know 25% is less than 50%, so we know this number has to be less than 1,200. 1,400 is way too big. Now, I'm making these videos both for teachers who are looking for some test techniques to teach as well as just math content, but also for students. This note is kind of for teachers, however. Really, it's for students too, but it's something to point out to your students, and that is that a lot of times the answer choices that are wrong are not just a bunch of random numbers. They have to look reasonable. So, for example, this $200 If you take 25% of 800, you get $200. Now, we're not finished with the problem yet when we do that. We've got more stuff to do, but that is a very common type of wrong answer, an answer that is a number you get partway through the problem. 600 you could get by subtracting that 25% instead of adding it. Or you could go back to saying, oh, I remember something about percent discount, and you're supposed to take the 25% and subtract it from 100%. That gets you 75%. Then you take 75% of the number, and that gets you the sale price. Well, guess what? Write math for the wrong question. This, by the way, math teachers, is why I teach the same steps for every single type of percent problem. We solve them with proportions. So even on that percent discount, I'm not going to do it that way. I'm going to make them calculate 25%, and then I'm going to make them add it on. Okay, 800 is a number that shows up in the problem itself. That is another kind of answer choice you might see among wrong answer choices, just things that exactly copy numbers that are in the answer choice. A student who doesn't know how to do it is going to be attracted to a number that they've already seen. Okay, let's move on to the next example, and that will be shorter because I won't have the digression of talking about how they make wrong answer choices. Second example, we went from question 3 to question 2. Don't question that, however. That's just the way things are. Now, consider the advertisement below. Yes, consider this advertisement. We have nothing better to do, so we're going to consider it. It says sale, paper sale, $25 per box, 5,000 sheets per box. Now, folks, that's actually a very good price for paper. So if you got a printer at home, go ahead and pick that up at your local Staples or Office Max or Office Depot or whatever there is out there now. If any one of you office supply companies would like to sponsor these videos, I will reshoot this video and put only your company name because I am shameless and would be happy to have your support. Now, besides the fact that this is a good price for paper, we know that 5,000 sheets cost $25, and it all happens to be in one box. So we know if we get more than 5,000 sheets of paper, we're getting more than one box full of paper, and we know the price is going to be more than $25. With just that information, and by the way, this is not a very hard problem, so most of you can probably just come up with a solution, but this is a common theme in which expression problems. When you actually work out the math, these are expressions. Remember, an expression is simply doing math stuff to numbers. I'm sure that's not the official definition, but that's good enough for us. So I'm going to pause right now. I'm going to use my calculator. I'm going to calculate, or what they would say on an actual math test, evaluate each of these expressions and see what it equals. And we'll come back, and together, you and I, and you and whoever else is watching this video, we'll see if there's any of these answer choices that actually just don't make any sense. All right, we're back. I saved you the trouble of doing the calculating, but this is almost always going to be a good idea on a which expression problem, especially if it's a word problem like this. And you can kind of imagine going into one of these Staples or Office Depot kind of places and actually making a purchase and having an idea of what a reasonable answer might be. So we see that A works out to be $100. It's $25 for one box. We need 20,000 sheets and not just 5,000. This seems reasonable. $500,000 seems like an awful lot of money for 20,000 sheets of paper. So that doesn't make any sense. Also, we see that this one works out to $4 for 20,000 sheets when it costs $25 for 5,000 sheets. In other words, it costs less to pay for more of the same thing. That never makes sense, which means this also isn't going to make sense. So we're down to two answer choices. You can probably realize 20,000 is not that far from 5,000 that we're going to get all the way up to $800 here. Probably that is the right answer, but if you couldn't even figure out that far, you at least are down to two answer choices. Now, this is a fairly easy problem to do, but I want to illustrate one other way of using common sense for answering a problem like this, and this works for a lot of proportion problems as well. All right, another way we can sort of use common sense is to sort of work our way through by using our fingers or making little drawings or things that are not really that math heavy. I will say this works particularly well with the proportion problems that I see on a lot of the practice tests. Remember, I don't get to see the real tests because I teach the tests. And then if I saw the real tests, I could just say, okay, answer 1 is C, answer 2 is B, just have them memorized. That wouldn't be fair. So instead of seeing the real tests, I see these practice tests, and I have to have a little bit of faith that they are similar. And most of the proportion problems on the practice tests are proportions that can often be solved by counting on your fingers, literally. I'm not making a joke there. Or in this case, since you can't see my fingers, I have very nice fingers, by the way. I have the best fingers. But you can't see my fingers, I'm going to do it by making a little drawing. And here's what I mean. 1 box of paper is $25. And we know that in that box is 5,000. Okay, that doesn't look like 5,000. That looks like sodo. Sorry about that, but you get the idea. Okay. What I have done, so that I don't have to draw this over and over and inflict even worse handwriting on you, is I've got some copies of this. So if I put a second box up here, now we see, well, you can do this math in your head. 5,000 and 5,000 is 10,000. And 25 and 25 is 50. So it's $50 for 10,000 sheets. And then we can draw another one and see that it is $75 for 15,000 sheets. And finally, we can see that when we get to 20,000 sheets, it's $25 for each of the 5,000s. It's going to be $100. So A was the correct choice all along. Now, this is actually a way you can handle a lot of the proportion problems on there. You might not have even known that, at least I think they wanted you to solve this like a proportion. But very often in a problem like this, you can kind of either count on your fingers, as I said, or do a little drawing like this and just sort of count your way up to the answer. I hope that makes sense because it's actually something that is useful, at least on the practice test, once or twice per test. All right, well, this example has actually turned out to be longer than the last example. And again, bear with me, and this is particularly something I want to point out to teachers. Really, students can benefit from this as well. If you recall, way back 3 minutes ago, we had eliminated this one, and this one because they just didn't make sense. We worked them out on a calculator. The answer choices did not make sense. We were left with 2. This problem is not real hard, but if you were stuck, we showed that you could use common sense to find your way to the answer. But there's another thing I want to point out, and that is this. When you have a word problem, and there's only one question involving that word problem, not several, each of which might use a different part of the information in the problem, but it's one problem, one question, the odds are very, very strong that you're going to need to use every number that's mentioned in the information and in the problem itself. So if you notice, D has 20,000, which is mentioned in the problem. It has a 25, which is mentioned in the information above the problem. It does not utilize the number 5,000 anywhere. I'm not going to guarantee that this is always going to be the case, but if you have not used all the numbers that you saw in the problem, that is a sign to go back and double check. You may not have finished the problem. You may just have come up with a wrong way about finding the answer. The only other one besides the correct answer that uses all 3 of the numbers is this one, and we had already eliminated that because that ends up to equal $6.25, which clearly doesn't make sense to get more paper than the original $25 box had. So I hope these things make sense, and it's a way to sort of analyze each problem from a common sense perspective, with that little bonus of making sure you're using all the numbers in the problem thrown in at no extra charge to you, the viewer. All right, a new Yoyo factory is operating at 80% of capacity. I'll translate that. If you're not sure what that means, this problem could be a little bit tricky. That just means that when it is making 80% of the total number of yo-yos it could be making if some people weren't loafing. When that happens, and it's always good to start by writing down information, when it's working at 80% capacity, they can make 4,000 yo-yos. All right, well, when those deadbeats get to work and they are operating at 100% capacity, not 1,000%, oh my goodness, that would be pretty impressive. They could operate at 1,000%. 100% of capacity, how many could they make? Well, we don't know yet. That's what we're trying to figure out. But think about it. I want you, when you see a number like 80%, I want you to think of a number that is most of, but not all the way to 100%. It's most of, but not all of the number. 10% is a very tiny chunk of the number. So a way to remember that, if there's something you really wanted, let's say, I'll skew this towards our younger population, the new Xbox, and for some insane reason, one store is selling them at 80% off, and the other store is selling them at 10% off. Well, you're probably going to wait in line all night and elbow your friends in the face to get to the front of the line when it's an 80% off sale. Why? Because you know that 80% off is most of the price, almost all of the price being subtracted away. 10% off is just a small amount. Yeah, you'll go to that store if the 80% store is out, but you're not going to get as excited about it at all. Okay, so 80% means a number that is most of the way, but not all the way, to the number that is 100%. So that means that this number here is just going to be a little bit bigger than 4,000. 4,000 is going to be most of, but not all, of the number that's missing. Well, the answer can't be 800. 4,000 is more than 800. We said it's not all, and it's certainly not going to be more than all of 100%. Same with 3,200. 4,000 is more than 3,200. That doesn't make sense. These two make sense. Sometimes we can't eliminate down to just one answer using common sense. That's okay. Our point is, how do we handle problems that we're not quite sure how to do? 7,200, you might leave it. That's okay. Then at least you have a 1 in 3 chance of guessing right if you have nothing else to go on. But on the other hand, you might think about how 4,000 compares to 7,200. 4,000 is more than half of 7,200, but it's not most of the way to 7,200. It's still pretty far away from 7,200. So I think, well, I know the answer. I know for a fact that that's not right, but I think you could probably eliminate that. Either way, you've got either 2 or 3 answer choices to choose from. Now, here's another little trick. Wrong answers in the math section will sometimes distract you by using numbers that show up in the problem. I mentioned that before. So I see a 4, an 8, 2 zeros. This has a 4, an 8, and 2 zeros. If you had nothing else to go on, you could eliminate C and guess D. I'm not going to say that's going to work every single time, but it's just something to keep in mind. So I hope this makes sense, that we can eliminate answer choices when we're talking about percentages by kind of knowing 80% is a number that's very close to 100% of the number, and numbers like 10 and 20% are going to be very low amounts of the original 100% number. Now, what I'm going to do in the next video is talk about the fact that this test is multiple choice. Well, there's a lot of ways to what I call legally cheat with multiple choice, and one of them, and this is legal cheating, by the way, absolutely legal, you're not doing anything illegal here, is if you know how to take 80% of a number, you could kind of go through and just take 80% of each of these answer choices and see which one leaves you at 4,000. It turns out it is D. 80% of 5,000 is 4,000. So if you're a little bit familiar with percents, that's one way you might do it. And that's what the next video is going to talk about. how to try out each of the answer choices to see which one is right.